Welcome back to my channel again. So today we are going to continue to where we left in the other session. So here I've written this for easy of us solving this problem. So this is a problem here. I have two problems on the board, and probably you have to see the way that you can be able to see me. So here we have dx, and then we have ln x to power 8, right? So we're going to differentiate this thing using chain rule. Now let's see. I don't know whether this chain rule or what one is. Yeah, let's see. Okay, this one comes in front, right? 8 comes in front here. What is inside remains the same. That's ln x remains the same here, ln x, and then 8 you subtract 1 becomes 7. So after that we find ln x, and this ln x, when differentiate ln x, it becomes 1 over x, which is this one. So once you find this one, we moved from here to here. Then now we come down to write the solution of this. This one remains above and this one comes down here. So this is the answer. So it's as simple as that. ln x becomes 1 over x, which is this one. And now this you'll have to multiply with this one. Then this becomes the answer like this. So let's move to the next one, which is this one. D over dx into this one. Okay, so here we're gonna do one thing. Yeah, 1 over, sorry, this thing is here. You can see it's like a fraction here, d over dx here. So you have to bring this on top, so that you can be able to rewriting it actually, so that you can be able to apply the rule. So here it becomes like this. Once you brought it up, it becomes like this. Okay, it becomes x cubed plus 9. Okay, x cubed plus 9 minus 3, because now it has come on top. Down here you see this was positive, now it's negative, it's reading negative, because now we have brought it up. And then now 3 will come in front. We differentiate this one, 3 comes in front, and then the rest remain the same. I think there's a mistake here. This should be 3, not 2. So this should be 3, because it's 3 here, 9, and this one we have brought it in front. So this one remains the same here. This one remains the same. And now we differentiate the inside part. Okay, we're going to differentiate this one. This we have brought in front. So what will happen is, if we differentiate this one, 9 will disappear because it's a constant, and this one will come in front here. This one will come in front. 9 will disappear. This will be 3x minus 2 minus 1, so it will be let me see. So this one we brought it here in front, and we subtract 1 here. Once you bring it in front and subtract 1, guys, it's very difficult to turn the board now and again like this. I get, okay, this one becomes now minus 4, which is this one, because minus 3 minus 1 becomes minus 4. Okay, so it means you have differentiated this one to this value. So now we are coming to the inside. The inside 9 will disappear. 9 will disappear. and then this one, when differentiate this, it will be 3x squared. I think there's a mistake here also. This is 3x squared. 3x squared. Yeah. Guys, I hope you are following this. Let me just to explain this point. Here we add a fraction up here, this one. So for us to be able to calculate this, we have to bring this one up. So we brought it up, and once you remove from the denominator to the numerator, then it becomes a minus, which is this one. Okay, so once we get this one, now we differentiate. So 3 will come in front here as -3, and then you subtract 1 here, so this becomes -4. You can see it becomes -4, and the inside, which is x squared, x cubed plus 9, remain the same here. Okay, so now that we have done that, now we're going to differentiate the inside, which is this one. So once we do that, 9 will disappear because 9 is a constant, and then this one, when you differentiate this, it will be 3, because 3 will come in front. So we have 3, then x, you subtract 1 here, it will be 3x squared, which is this one. So once we get this value, it means now we are going to bring this stuff down again, because it's a minus, to the numerator side, whereas we multiply these two. So it will be 9 minus 9x cubed, not 6. Here is a mistake. Be minus 9x squared, actually. Here, minus 9x squared over, this one will come down here in the numerator side. Now it becomes a positive. So you can see it's x cubed, x cubed plus 9 into 4 as a positive. So this is a solution. This is the answer. Okay guys, so we are going to do more. Let's do more examples. We have done ln x. Let's do the radical. Let's do a radical. Oh, first let's do sine. Let's do sine. I write and I'll show you. Sine tangent of x to power 5, x to power 5. Okay, let's do this. So we're going to differentiate this thing which I've written on board. Okay, now let's start. When you differentiate this, it become cosine. Okay, into sorry, 1 minute. Yeah, the rest, the inside, this remain the same. So we have tangent x power 5 to 7. Yeah, this remain the same, the inside part remain the same. I hope we are right here. Yeah, we are right. And then so we have done this one, that's cosine. Tangent x power 5 remain the same here. And then now we differentiate the tangent. We differentiate the tangent, this one, that will become secant squared. Tangent and derivative of this secant squared here. So secant squared, the inside will remain the same, which is x to 5, right? X to 5. So now we're going to differentiate x to 5 next, because I've run out of space, so I'm moving down here. So let's differentiate x to 5. What will that mean? So x to 5 5 will come in front of x. 5 comes in front according to the power rule. So we have 5x. Then here you subtract 1. Okay. So it means 5 minus 1 will be 4. 4. Okay. So this will be the answer. This will be the answer. So it goes from here up to this point. Then because there's no space here, I've moved down to this, and the entire of this thing is the answer. You can copy it down if you want. Yeah, I'm just trying to make it as clear as possible. Okay, let's move to the next one. Let's move to something like a radical. Let's move to a radical. You guys have to stay out of the focus because you need to see the board. You don't need to see my head. Okay, let's go to the radical, which is d over dx over d over dx, and you can have x squared minus 6. Okay, now this will be equal to, so first of all we have to rewrite it. Okay, this is a radical. You are going to rewrite this, and once you rewrite it, it will be d dx. I guess I meant d dx, but I'm seeing here I've written just dx, and x cubed minus 7 here. Then it like this. X squared minus 6, x squared minus 6, and to get rid of this radical, I've written there, it becomes half, is the same as half here. So, okay, so once we have done that, now we can bring half in front, so it will be half, and then the inside will remain the same, which is x squared minus 6, x squared minus, I'll show you, I'm just first of all writing, and 1 minus negative 1 minus 1 be negative half, and then you differentiate the inside, which would be you differentiate the inside, which is this, the 6 will disappear, and this will be 2x only. Okay, now I'll show you this thing that I've written down. d dx, this is a radical, simple, you can see it. You have to rewrite it, so we rewrite it here. Yeah, d dx, I think this I meant d dx, this thing. So we are having this here, okay, and we have put half, so we remove this, so we are put in a form that we can be able now to differentiate it. So what happens next is that half will move in front, and the inside will remain the same here. So we see that this has come down because we have subtracted 1 from half, then it becomes minus half. Because half minus 1, then it becomes negative half. This is what we have written here. Okay, and then we do differentiate the inside. The constant will disappear, which is a 6, and x will come in front, and this is the 2x we have here. So after that, and then we have to multiply x 2x times half, so it will be 2x, and because we have a minus, so 2 will remain on in the bottom, and then we'll have x squared minus 6, x squared minus 6. I'll show you. I'm just first of all writing into positive half. So now you see what I've done. This one, having done this from up here, I think you're following. First of all, we had to change this into this form so that you can be able to differentiate. When you write this one is the same as this half into this means the same thing. So once we write this, now it's in the form we can be able to differentiate. So this one comes in front and this remains the same according to the formula which I have written here like this. This is minus 1 because we have to subtract. Whenever we do this, we bring this in front according to power rule. We have to subtract 1, so it becomes -1 here. Okay, comes -1 here. And then now when you multiply, we differentiate the inside part, the constant will disappear and this will become 2x. Okay, so we have this, then we multiply this into this, which will be 2x, and this one, because it's a minus, we bring it down like this. And then this is the same as, this thing is the same as, you can write it now like this, 2x into 2, let me remove this, into 2x squared minus 6, x squared minus 6. So instead of writing this, you can just write it like this, x squared, it's not, I'm not writing very clearly, x squared minus 6, right? X squared minus 6. So we can write it like this. We have brought the radical back, which means the same thing actually. This means the same thing as this, and this is x squared minus 6. So we have put the radical back. This is on top, and 2, this one is here. Okay, so we have solved that one. That is the answer actually. This is the answer. This is the answer. I hope you are following. Let's go according to the formula and everything will be fine. So I think there are so many examples that you can do in the chain rule. We are not going to do everything, you know. And maybe I'll do one more and then we end it here. Let's do D. Let me see what we do, which is the easiest one to do here. Nothing is easy, they're all the same. D over dx into sine is a trig function, sine 4, to tangent cosine x squared, right? So I've written this thing here. You can solve this problem. I think it's clear, you can see it clearly. D dx, you differentiate sine into the value which is tangent into cosine x squared. So let's come down to D dx. The problem, this place is very hot guys, I'm really sweating. So we are having sine, we are rewriting it sort of. So left side, tangent, sine tangent, cosine, it is cosine, x squared, and then we have 5 here. So we have rewritten it like this in this format, from this to this, so that you can be able to differentiate. In this form we can't be able to differentiate. We have sorry, what have I written here? Sine 4 So this is 4 actually, so I'm writing 5, this is sine 4. So we'll be able to differentiate this one. Now let's see what happens next is that we have to bring 4 in front. So 4, and then we have a sine. I write, then I show you sine, tangent into cosine x squared, tangent x squared, and then we have now here we're going to subtract 1 from 4 to 3 okay. Let me write the entire thing, then I'll explain you. Then we have cosine, next we have cosine, tangent, cosine, tangent, they remain the same, right? Tangent, cosine, x squared, sorry, right? And then we have which is 4. I'm running out of space. Which is 4. No, sorry, it's not 4. We are going to have secant squared, cosine tangent x cubed, yes. Then we are going to have secant squared into cosine x squared, into sine minus sine x squared into now the last part that we have to 2x. So our written is quite lengthy, you can see. So I'm going to explain you this thing. So here we have d dx, we are differentiating this thing like this, but you have to write it in the form that you can be able to differentiate. You can differentiate it like this, so we rewrote it here like this, okay. So 4 is here, this 4 we transferred it here. So now we have to bring it in front, and the inside will remain the same. So we bring it in front, this stuff remain the same as you can see, okay. Then next we differentiate sine, which will become cosine. The inside will remain the same, which is this one. If you are following, I think by now you are seeing the pattern. And then now we come to the tangent. You differentiate the tangent, it becomes secant squared, and this remains the same, okay. This one remain the same. Then we differentiate this one to the sine minus sine, and this one remain the same. Then we differentiate this last, becomes this, and then this is the last part of it, this is a solution, okay. So I hope you are seeing this thing, and you can copy it down if you want and analyze it at your own free time. Guys, I'm trying to bring it close so that you can see it. I hope you are seeing this value here. This value is 2x, because I'm seeing that it's not clear here. And this is x, this is x squared, and this is minus sine, this is minus sine, and this is a cosine x squared. This is a cosine x squared. From here it doesn't look clear, maybe from your side you are seeing it. And this secant squared. So this is the entire expression, starts up there up to here, and this is a solution. And the solution is the answer is quite lengthy, as you can see. If you are following, I think you are seeing what I'm doing. Actually, you apply the formula in the chain rule, and you get this stuff just like this. If you have any question, you can write in the comments, then I'll answer you back. Okay guys, thanks for watching. That's all I have to show you today. This place is very hot. I'm sweating, practically sweating. It's summertime here. So please share, subscribe, like and comment as I bring you more mods. If you are a lover of mods, then we are in for a big deal. So bye for now. See you later. Bye.